A self-balancing robot may look simple from the outside, but making it stand, move, and recover by itself takes a lot of tuning. Now, in this video, we move to the most important stage, calibration and control. I'll tune the PID values, calibrate the sensor, test the balance performance, and control the robot using a custom Android app. In the first part of this project, I built the complete robot body and electronics. Before we start the tuning process, I want to correct one thing I missed in part 1. I forgot to show the voltage sensing resistor connection for the battery monitoring circuit. For this, I used a simple voltage divider with a 1 kilo-ohm resistor and a 2.2 kilo-ohm resistor, so the Arduino can safely read the battery voltage through the analog input. This voltage value will be sent to the Android app over Bluetooth, and later in the video, I'll show how to calibrate it using a multimeter. Next, let's upload the firmware to the Arduino board. I've added the complete program download link in the video description, so you can download it and follow along with this setup. When the robot is powered on, the display will look like this until we connect the Android app and enable the robot. Now, let's connect the phone to the HC05 Bluetooth module. Next, go to the Google Play Store and search for my self-balancing robot app called AL BalanceBot. I'll also provide a direct APK download link in the description for a limited time. After opening the app, tap the Connect button and select your robot to establish the Bluetooth connection. After connecting to the robot, you can see the battery voltage displayed here in the app. Next, we need to calibrate this battery voltage reading. For that, measure the actual battery voltage using a multimeter and compare it with the voltage shown in the app. We will use these two values to calculate the battery calibration factor, so the app can display a more accurate battery voltage. Now, enter the calculated calibration factor into the program. After updating the value, upload the program to the Arduino board again. Now, the battery voltage reading is calibrated. Okay, now let's close the robot head cover and secure it with the screws. After that, we can power on the robot and continue with the gyro sensor calibration process. Next, we need to calibrate the gyro sensor. For this step, place the robot upright on a stable surface or hold it carefully in the balanced position without moving it. Then open the app and use the calibration function to calibrate the MPU6050 sensor. Make sure the robot stays completely still during this process, because any movement can affect the calibration accuracy. Before calibration, you can see that the angle reading is not correct. First, we need to calibrate the gyro sensor using the app. After that, we calibrate the robot's actual balance point. Once both calibrations are complete, the angle reading will be corrected and the app will show the actual balance position as 0. In the configuration page, we can set the maximum tilt angle. Maximum tilt angle is the safety limit for detecting when the robot has tilted too far. We can set the battery warning voltage. Battery warning voltage is the level where the app shows a low battery warning in the app. Then tap the Save button. Now we can enable the robot using the Enable button. Once enabled, the stepper motors will energize and the robot will be ready to start balancing. When we manually tilt the robot, the motors automatically correct the angle and all the live data is displayed on the graphs. We can also control the robot's movement from the app using the forward, reverse, left, and right buttons. Now everything is ready, so let's test the robot's performance. You can manually tune the PID values from the app using the P, I, and D parameters. After saving the values, they will be applied to the robot immediately. That's it for this video. Now the robot is fully calibrated, tuned, and controlled through the Android app. You can find the firmware, app link, wiring details, calibration steps, and all project information on my GitHub. I'll add the GitHub link in the description. Thanks for watching, and subscribe to AmithLabs for more robotics, Arduino, and electronics projects.